They say here, the first part is easy. I mean, the first part is just applying the infinite sum formula for a geometric sequence. You have the R value, the sum to infinity you've got that. So they're going to ask you for the first term, which they do. And then they ask you to find the 8th term. Now you know that term 8, calculate the 8th term will be AR to the power 7. So for those 4 marks is literally just finding those values and substituting them. I want to get to the sigma ones. Let's have a look what they say. This one says it doesn't look nicely here. So let me write the rule or the actual sigma problem down for us. They say sigma, when k starts from 1 to n, of 3 times 2 to the power 1 minus k is equal to 5,8125. Okay, so what did they tell us? They tell us the sum of the, remember what sigma means. Sigma means you're adding, you're taking the sum of something. And that something is expressed next to the sigma. That is the general term. Okay, so here, this means you're taking the sum, just to remind yourself. And this here is the general term, tk, and that is the sum to n terms of the sequence expressed on that side. Okay, so let's quickly find the first three. They say calculate the value of n. So let's quickly go and find the first 3 terms here. Term 1, k is 1. 1 minus 1 is 0, so 3 times 2 to the 0 is 3. Term 2, I make k 2, so 2 to the power 2, 1 minus 2 rather, is 3 over 2 to the power of 1. Make the power positive. And then if we work with our third term, 1 minus 3, this will be 3 over 4. So we've got the first term, we've got the constant ratio. The constant ratio seems like it's a half. Now we can find the sum. We're going to acknowledge here for Sn, we're going to acknowledge that our constant ratio is smaller than 1. So Sn will be A, 1 minus r to the n over 1 minus r. Sn I have 5,8125. The first term I've got it is 3. 1 minus the constant ratio we see is a half. We don't know what n is in this case, and we know that 1 minus a half at the bottom is a half. So if you have a half at the bottom, all you need to do is times with 2 over 2. It's gone at the bottom, and that becomes a 6. Okay, so let's go into the next phase here. We've got 5,8125, which is equal to 6 times 1 minus a half to the power of n. Now, folks, I'm looking for n. So it's the same situation as previously. If I cannot get those 2 bases the same matrix, I'm going to grab my logs. Okay, so let's see what happens here. If I now divide by 6, I've got to take 5,8125. I need to divide it by 6. I need to subtract 1, and that will equal, on the other side, minus a half to the n. Remember that n does not have dominion over the half. Oh, sorry, over the minus. It has dominion over the half only. So the negative is just there. Hopefully it goes away. Now, folks, look at this. If you put this into your calculator, okay, you're going to come up with 1 over 32. So I can, a negative 1 over 32. So we get minus 1 over 32 is minus a half to the n. Okay, what can I write this as? I can write it as minus a half to the power of, what is it, 5. 2 to the 5 is 32, gives me minus a half to the n, so n is indeed 5. My minus is cancelled, I can drop my bases. There's 5 terms in the sequence. Okay, so that was a little bit of work applying the sum formula to answer this, because sigma means sum of. Now for the second part, 3.4. I loved this part. 3.4 says the following. Let me just make space for us here. 3.4 says, where's the question? It's up there. Okay, I need to write this down. So 3.4 says, if the sum, when k goes from 1 to 20 of 3 times 2 to the power of 1 minus k, if that thing there is equal to p. In terms of p now, they're going to ask us to write another sigma. Okay, so they're telling us the sum from 1 to 20 of that sequence we've been working for, let it equal p. Now they say, in terms of p, we need to find the sum when k goes from 1 to 20 of 24 times 2 to the power of minus k. Now that's interesting. That's a very, very interesting question, because we do not have, there's a 3 missing, there's a 2 missing if you look at this, so there's quite a few things missing from this equation. Let's underline them. There's no 3, there's a 24. Here I need a 1 minus k. Now for me to get a 1 minus k, I need a 2 here. So I'm in trouble. Where can I get the 3 from? I should ask myself now. And where can I get the 2 from? So remember, this is orange and this is yellow. I hope it shows nicely at home. So I've got to change this to look like that. I must change everything because this is the condition. For me to use p over here, I've got to change this. So I'm going to start and I'm going to say, okay, this is 20, the sum from k equal, starting at 1 and ending at 20. That I know is 3 times 8 is 24. Times, then I still have 2 to the minus k. I do not have 2 to the 1 minus k, so I need a 2. So I'm going to take this 8 here, and I'm going to break it up into, where's my color? 4 times by 2 times by that part over there. Now, folks, you can see, for me to be able to use a p now, the only thing that stands in the way of me and p is this 4. But 4 is a number. All I'm going to do is remove it. Look at this. I'm going to say this is 4 times that sequence, k from 1 to 20. It's one of your properties of this, these sigma notations. 3 times, and there I've got 2 to the 1 times 2 to the minus k is 2 to the 1 minus k. I've got exactly what I had over there.